Welcome back, guys. This is Shrikant. Today we are going to talk about data warehouse. Let's change the font. Data warehouse. Okay, so what is data warehouse? Data warehouse is a central repository where we'll have all kind of data. So data warehouse is kind of a relational database management system or the database where we'll have the data from the different places. So you can take the data from the SAP, you can take the data from Oracle, you can take the data from the Excel file. So you can take data from multiple sources, and then that data will go to the transformation engine. So first we'll extract, then the data will move to the transformation engine, and the transformation will happen, it get merged, right? And then after transformation it get loaded to the data warehouse. So when we design a system called as a data warehouse system, we need to follow two kind we basically have a different kind of schema, and we need to choose any one of them. So mostly people follow two different kind of schema, and they choose anyone which is basically best for their warehouse system. So the first kind of schema is called as the star schema. Another type of schema is called as the snowflake schema. Right, snowflake schema. So I'm going to talk about star schema and also going to talk about the star schema. Okay. So before understanding this kind of designing models or schema model, we need to understand two important type of table. The first type of table is called as the dimension table. Another type of table is called as the fact table. So this is called as the dimension modeling. Important thing, dimensional modeling, right? So what is dimension table? So dimension table, you can say it's a master table where we'll have the master entry. Like for example, if I say customer, so that table will have the master information of all the customer, like customer name, customer last name, customer middle name, customer city, customer location, all different kind of customer information will be placed in a one table, right? And every record will have a unique id, that is basically primary key of that table, right, which we will use in another table. So that key is very important. So when I talk about the master data, the master entry will go to the dimension. Okay, this is one example. Another example, if I talk about the if I talk about the product, so product, every product will have some different categorization, different things, right? So if I'm representing inventory, so inventory identifier, inventory name, then inventory mpn, then upc, right? All the different things. So these are a master thing, and those all the master table we termed it as the dimension. And in dimensional modeling, dimension are such a subject oriented thing where we can use to group by the fact information. So if I can say for dimensional modeling, I would have the customer, the master data, or sales data, basically not sales, actually customer, then product, right? This is just for information. Then what is fact? So fact is a table where we'll have the measures. Measure is what? Measure is something like where we'll have the numeric data. That data will be used for the aggregation purpose. Okay. Now, if I talk about the sales data, so what kind of information we'll have? We'll have the customer, we'll have the product, and we'll have the sales information, what customer has purchased from us, right? So that kind of information. So what customer has purchased from us means we can say, if we are selling some inventory, so quantity would be there, the price would be there, the uh, final price, right? So the final amount would be there. So these are then some numerical things which would be there. And the fact table will contain the mapping id from the customer, which customer has taken the which customer has taken the product, that customer id information, then product id from the product table, right? So and after that the fact table will contain the value. So what quantity has customer purchased? So quantity, then price, so you can use this price into quantity to get the total amount, right? So these are the measures, and this should be the part of the fact table. Hope you understood. So dimension table will have the master data where we'll have the IDs, and that ID we will use in a fact table, and the fact table is a table where we'll have the measures. Measures mean the numericals value which we can use for the aggregation or the calculation purpose. Okay, so now we understood these are the two important things. Then we are going to talk about schema. Now we are going to talk about the first kind of schema is called as the star schema. So star schema is a kind of a schema where we have the structure. I'm going to show you the, let me find out the image. So you can get the image over the net, that's not a big thing. So you can come here and you can just type star schema. Okay, this is the best example. So star schema is a kind of schema in data warehouse modeling where what will happen, where 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 basically the fact table, this is the fact table, sales table is a fact table. If you see here, total, quantity, discount, these are the numerical thing, right? And the dimension table are there. So every dimension table to the link with the fact table, this is what in a star schema. So star schema, in the star schema, fact table will be the middle table, and fact table would be the middle table, and the dimension table will be side by table. So all the dimension table will be linked to the fact table. This is what we call as the star schema. Very simple. So you can create dimension for the customer, right, like this customer ID, customer name, address, city, zip. You can also create the dimension for the product, right? So product dimension, product ID, product name, and these two dimension are linked to the centralized table called as the sales table, which is basically our fact table. And here you can see here the total, quantity, discount is there, and this product ID, order ID, customer ID, employee ID, these are from the different dimension table. So in fact, in fact, basically in star schema, the fact table is linked to the different dimension table. This is what we call as a star schema. Okay, now let's try to understand the snowflake schema. Snowflake schema is also very important, but based on your requirement, you need to choose any schema and you need to design your warehouse. So what happen, in snowflake schema, this is our dimension, time dimension, product dimension, right? This is customer dimension, and this is employee dimension. In star schema, only there was only a one fact table, and that fact table are linked to all the dimension table. But in case of snowflake schema, you will find here this product dimension is not directly linked to the sales table, right? And the department dimension is not directly linked to the sales one. It is linked through the employee dimension, right? Department dimension is linked to the employee dimension, and then employee dimension is linked to the sales. So same is the case for the city dimension. City dimension is directly linked to the sales. It is linked through the customer dimension. So the basically what happened in snowflake schema, in snowflake schema, dimension are not directly linked to the fact table. So basically what does that mean? It mean, I mean basically all the dimension table are not linked directly to the fact table. This is called as a snowflake schema. In snowflake schema, there are again hierarchy followed by a dimension. So this is what, for example, if we are talking about the date, so in a date we'll have quarter, year, month, right? So I simply join the date dimension, it won't come directly. So we need to come to the order like date, month, year. So these are the different hierarchy for the date dimension. So in snowflake schema, all the dimensions are not directly linked to the fact table, but in a star schema, all the dimensions are linked to the fact table. So this is basically the difference between the star schema and the snowflake schema. In coming videos I am going to show you how to design this one, that will be helpful. And the next part for this video is data lake. Data lake is very simple. In data lake we don't need to do the transformation activities depend. So data lake is also a central repository where we will have the data, which will basically have the structured data, which will basically have the unstructured data, and which will be having the semi-structured data. So all kind of data. So you can have the rdbms, the stable data. You can also have the json, xml, or different kind of file type data. Also you can have the image, video data, right? So data lake is kind of a central repository where you just dump the data, and everyone can have the access, and they can access the data, and they can take the data from that location, and they can perform the transformation, and they can design their system, right? So you can say in my data lake the data will appear, and from my data lake I can take the data, and that data will move to the data warehouse, right? And from data warehouse we have a different concept called as a data mart. For example, I'm having a one data warehouse, and now I want to distinguish every department data. For example, sales data should be a separate thing, and accounting data should be a separate thing, and the customer data should be a separate thing. So every different data is called as the data mart. So if you combine all the data mart, you will get the data warehouse. And this is the simplest way to understand the difference between the data warehouse and the data lake. So data warehouse you need to perform, and you need to follow the rdbms rule, but in data lake you don't have such restriction. You can just dump the data into the data lake one. And thanks for watching our video. Have a great day ahead.